Hello students, in this video I'm going to take up remaining numericals of chapter simple machines. So before getting into the questions, please keep your book along with you because it will help you. Now move to question number 12. In the question number 12, a single pulley is given to you and the load for this pulley is 27 Newton and its efficiency is given as 90%. You have to calculate mechanical advantage, effort, and then the frictional force. Now, as we know, efficiency is equals to work output upon work input. Now, work input means work done by the user. So, work input will be equal to effort into displacement. So, we have to calculate effort, and work output will be equal to load into displacement. So since there is a single pulley, so both the displacement will be same, so both displacements will get cancelled. And now since efficiency is given in percentage, so to get the exact value we have to divide 90 by 100. So now the equation looks like 90 upon 100 is equals to load, that is 27. Since displacement, both displacement will get cancelled, so 27 upon effort. Now if we can just cross multiply the equation, we get effort is equals to 27 into 100 upon 90. On solving, we get effort is equals to 30 Newton. Now we can simply calculate mechanical advantage by using formula L upon E. L is given as 27 and E is 30, so mechanical advantage will be equal to 0.9. Now since we have applied a effort of 30 Newton and we are getting output only of 27 Newton, which means the remaining force will be consumed in the friction. So basically friction force is equal to effort minus load, so 30 minus 27 will be equal to 3 Newton. यहाँ पे जो फ्रिक्शन फोर्स का फॉर्मूला आप ऐसे भी समझ सकते हो, क्योंकि आपने जो टोटल इनपुट वर्क करा है वो 30 न्यूटन है और जो टोटल आउटपुट आपको मिल रहा है 27, तो इसका मतलब जो भी हमारा फोर्स या जो भी वर्क वेस्ट हुआ होगा वो बेसिकली फ्रिक्शन में ही गया होगा. देयरफॉर फ्रिक्शन फोर्स इज E minus L. आई थिंक नाउ यू कैन अंडरस्टैंड इट. Now moving ahead, we will solve question number 11. So question number 11 में बेसिकली हमारी प्रॉब्लम नंबर जो 7 है उसी को उन्होंने डिस्क्राइब किया. उन्होंने कहा है कि जो सीसॉ में दो बच्चे थे हमारे, एक 40 किलोग्राम का, एक 30 किलोग्राम का. दे वर सिटिंग ऑपोजिट टू वन ईच अदर. तो अभी क्वेश्चन ये बोल रहा है कि अगर जो 50 किलोग्राम वाला जो बच्चा है वो 50 सेंटीमीटर एक डायरेक्शन में जाता है इन 1 सेकेंड, तो आपको ये कैलकुलेट करना है कि 30 किलोग्राम वाला बच्चा नीचे की तरफ कितना जाएगा. तो आप फिगर से देख सकते हैं. यहाँ पे देखिए ये एंगल थीटा है एंड यहाँ पे भी एंगल थीटा है. सिंस बोथ दिस थीटा 1 एंड थीटा 2 आर वर्टिकली ऑपोजिट एंगल, सो now equating theta 1 and theta 2, since theta, now अभी एक फॉर्मूला पता है हमें, एंगल इज इक्वल्स टू आर्क अपॉन रेडियस. तो यहाँ पे आप देख सकते हैं जो x है, द डिस्प्लेसमेंट ऑफ द बॉय हैविंग मास 40 kg, वो हमारा एक आर्क का काम करेगा. सो थीटा 1 विल बी इक्वल टू आर्क अपॉन रेडियस. सो अगर जो x हमारा आर्क है तो रेडियस जो होगा वो एफर्ट आर्म के इक्वल होगा. एफर्ट मीन्स द डिस्टेंस बिटवीन फल्क्रम एंड 40 किलोग्राम बॉय. सो रेडियस आपका कितना हो जाएगा 120, एंड हमें पहले से गिवन है जो डिस्प्लेसमेंट है 40 किलोग्राम बॉय का वो 50 है. एंड यहाँ पे सेकेंड तरफ 30 किलोग्राम वाले बच्चे का डिस्प्लेसमेंट हम लोगों ने y लिया हुआ है, सो y एंड अगेन रेडियस. सो ये जो छोटे बच्चे का जो 30 किलोग्राम वाला है उसका जो रेडियस है वो 160 सेंटीमीटर होगा. नाउ ऑन सॉल्विंग this we can easily calculate y as 66.6 and अगर जो हम उसको राउंड ऑफ करें तो आंसर हमारा 67 सेंटीमीटर आ जाएगा. नाउ अभी बी पार्ट में हमें क्या था, वी हैव टू कैलकुलेट द एवरेज स्पीड of the smaller boy. So speed is equals to displacement upon time. Since displacement was calculated as 67, so 67 upon 1 is equals to 67 centimeter per second. Now we have to calculate average velocity in complete swing. So complete swing में हम जानते हैं कि एक बच्चा ऊपर जाएगा और फिर अपने इनिशियल पोजीशन पे आ जाएगा. तो जब complete swing की बात करेंगे तो डिस्प्लेसमेंट हमारा ज़ीरो हो जाएगा, एंड सिंस डिस्प्लेसमेंट इज ज़ीरो, therefore average velocity will also be equal to 0. Now moving ahead to question number 13. In this question you have been given two pulleys. One is fixed pulley and second pulley is movable. It can move up and down. Load, mass of the load is given as 15 kilogram. So to get load, 15 is multiplied by small g, so we'll get L is equals to 15g Newton. Now we have to calculate velocity ratio, ma, and efficiency. Now from the figure we can say that this load is equal to the this t and plus this t, because this load is acting downward, and in this pulley there are two forces. This is the first tension force and this t is the second tension force. So L is equals to t plus t, that is 2t. Now we can easily figure out that effort is always equal to t. Now mechanical advantage is equals to L upon E, so 2t upon t, tt will get cancelled, so ma is equals to 2. Now we will calculate efficiency, since efficiency is equals to ma upon Vr, and Vr, now sorry, from the B part we will first calculate Vr, then we come to the efficiency. Now look at the B part. Now if distance of the effort arm is 2x, मतलब इस रोप को अगर जब मैं 2x डिस्टेंस से नीचे खींचूंगा तो ये जो पुली है वो हमारा x ऊपर जाएगा, बिकॉज वो जो 2x डिस्टेंस होगा यहाँ पे इस रोप और इस रोप दोनों में डिवाइड होगा. सो विच मीन्स अगर जो लोड की एफर्ट की डिस्प्लेसमेंट हमारी 2x है तो लोड की डिस्प्लेसमेंट सिर्फ x होगी. देयरफॉर Vr is equals to dE upon dl. dE stands for displacement in the effort, so displacement in the effort is equals to 2x upon x, so we'll get Vr as 2. Now third part we have to calculate efficiency. Efficiency, as we all know, is equal to ma upon Vr. Since both are equal, therefore efficiency will be equal to 100%. Moving to the next question. This question talks about a 4 pulley system whose load is mass of load is 24 kilogram. Now we have to calculate, first part is velocity ratio. So again assume displacement in the effort arm is equals to 4x. Since there are 4 pulleys, so displacement in the load is divided into 4 equal parts, which means displacement in the load is only x. Now Vr is equals to dE upon dl. dE is 4x and dl is x, so x will get cancelled, so velocity ratio is equal to 4. Now we know that ma is equals to load upon effort and load mass is given. So अगर load आपको निकालना है तो आप 24 को g से मल्टीप्लाई करोगे. सिमिलरली एफर्ट आपका 10 किलोग्राम दिया हुआ है, so effort mass 10 kilogram दिया हुआ है. So if you wish to get effort, you will simply multiply 10 by g, so g will get cancelled, so ma is equals to 2.4. Now again we have to calculate efficiency, which is ma upon Vr. Now percentage efficiency to get percentage efficiency we will multiply this value by 100, so we'll get 60%. Now move to question number 17. In question number 17 you have been given the value of F, and the mass of the load is 20 kilogram, and displacement in the distance in the load is 50 centimeter. Effort आपको दिया है 50 Newton. You have to determine the distance moved by the effort. So we know that velocity ratio is equal to dE upon dl. dE is the displacement in the effort. So since Vr is 5, so replace the value of Vr as 5 and dl is equals to 50 centimeter. Now simply cross multiply it, so displacement in the effort term will be equal to 250 centimeter. That is, if you wish to convert this centimeter into meter, divide by 100. Now we will get DE as 2.5 मीटर. अभी आपको क्या कैलकुलेट करना है? वर्क डन बाय द एफर्ट. सो वर्क डन बाय द एफर्ट का मतलब होता है इनपुट वर्क. सो इनपुट वर्क इज इक्वल्स टू एफर्ट इनटू डिस्प्लेसमेंट इन द एफर्ट आर्म. सो एफर्ट आपको 50 न्यूटन का दिया हुआ है एंड डिस्प्लेसमेंट 2.5 न्यूटन है, तो मल्टीप्लाई करोगे आप 125 जूल आ जाएगा. नाउ वी हैव टू कैलकुलेट input work. Sorry, ये जो input work लिखा है, this is not actually input work, this is output work, because whenever load is involved we will calculate output work. So input, this input is not correct here, this will be output. So now we will calculate output work. So output work is equals to mass of load into G into DL. Now DL is the displacement in the load, so mass of the load is given as 20 kilogram, G is 10, and displacement in the load is 50 centimeter. So 50 centimeter आपने मीटर में कन्वर्ट करना पड़ेगा, so डिवाइड बाई 100 करेंगे, सॉल्व करेंगे, तो जो आपका आउटपुट वर्क आएगा, that is not your input work, that is your output work is equals to 100 joule. So again, अब सेम जैसे कि अभी हमने डिस्कस करा था एक लास्ट क्वेश्चन में कि यू हैव टू कैलकुलेट फ्रिक्शन फोर्स. सो फ्रिक्शन फोर्स जैसा कि मैंने कहा था, आपका जो भी यहाँ पे भी जो लॉस होगा वो आपका टोटल इनपुट वर्क जो आपने करा हुआ है माइनस जो आपको आउटपुट पे मिल रहा है, विच मीन्स सिंस योर इनपुट वर्क इज़ 125 जूल एंड आउटपुट वर्क इज़ 100 जूल. सो 125 माइनस 100, द लॉस इन द वर्क इज़ इक्वल टू 25 जूल. सो लॉस का मतलब, मैं लॉस की बात करूँ या फ्रिक्शन फोर्स की बात करूँ, सो फ्रिक्शन फोर्स की जब बात करेंगे तो इनपुट फोर्स माइनस आउटपुट फोर्स होगा. जब हम वर्क लॉस की बात करेंगे तो इट विल बी वर्क डन बाय द एफर्ट एंड माइनस वर्क डन बाय द लोड. Now moving ahead to question number 18. In question number 18, you have to draw a level diagram of a block and tackle system having a velocity ratio of 5. So since velocity ratio is 5, therefore the number of pulleys will be 5. So मैंने upper half में 3 pulleys करी हैं, second half में 2 pulleys करी हैं. Now moving further in the question, load is given as 500 Newton, displacement in the load is given as 2 meter and effort is 160 Newton. So first part you have to calculate is efficiency. So before calculating efficiency, first we will calculate mechanical advantage. So mechanical advantage is equals to L upon E. Both L and E are given, so you get mechanical advantage as 25 by 8. Now we know that efficiency is equals to MA upon VR, so we get 5 upon 8, and since we require percentage efficiency, so 5 upon 8 is multiplied by 100, the result will be 62.5%. Now moving ahead, again we have to calculate loss of work. So loss of work is equals to again output work and यहाँ पे एक सिंबल देख रहे होंगे. इस सिंबल का मतलब ये होता है कि जो भी बड़ी क्वांटिटी होगी उसमें से छोटी क्वांटिटी अपने आप रिड्यूस हो जाती है. सो वी हैव आउटपुट वर्क subtraction input work. So input work is 1600 and output work is 1000. So simply loss of work will be equal to 1600 minus 1000, which is 600 joule. Now moving ahead to question number 20, I leave question number 19 as an exercise for you to solve. Now move to question number 20. There is a 5 pulley system whose mechanical advantage is 4 and load given to you is 5 Newton. Now MA is equals to load upon effort. So since now we can calculate effort is equals to load upon mechanical advantage. We can simply take effort to the other side and bring MA in the denominator. So effort will be equal to load upon MA, and since the value of load is 5 and MA is 4, so your effort will be 1.25 Newton. Velocity ratio is given as 5. Now in the part C you have to calculate efficiency. Efficiency again can be calculated by using formula MA upon VR. Now in part D you have to calculate total resistance due to friction. So for this to be calculated, we will refer to the figure in the last question. Now here in this figure you can see that basically now इस फिगर में आप देख सकते हैं टोटल जो डाउनवर्ड फोर्स एक्ट कर रहा है वो आपका केवल लोड है, which means your load is acting downward, and upward direction की अगर जो फोर्स देखेंगे, this is your first tension, this is your second tension, this is your third tension force, this is your fourth tension force, and this small t is your 5 tension force. So total 5 tension forces are acting in the upward direction. अगर जो मैं फ्रिक्शन फोर्स को नेग्लेक्ट कर दूं तो L इज इक्वल्स टू आपका आ जाता है 5t के, बट अगर जो मैं फ्रिक्शन फोर्स को रिड्यूस ना करूं और फ्रिक्शन फोर्स भी इसमें इंक्लूड कर लूं, सो L प्लस अगर जो फ्रिक्शन फोर्स को मैं कैपिटल R से रिप्रेजेंट कर रहा हूँ, सो विल गेट L प्लस R इज इक्वल्स टू 5t. आई होप यू अंडरस्टैंड दिस पॉइंट. बेसिकली जो फोर्स हम अप्लाई कर रहे हैं वो दो चीज़ों में यहाँ पे जा रहा है. पहला तो लोड को लिफ्ट करने में, और दूसरा सिंस यहाँ पे कोई भी ऑब्जेक्ट हो टोटली फ्रिक्शन फ्री नहीं हो सकती है, तो इसका मतलब ये हुआ कुछ ना कुछ फ्रिक्शन फोर्स इन पुलीज़ के बीच में, पुली और रोप के बीच में ज़रूर लग रहा होगा, उसको मैंने R से रिप्रेजेंट किया है. तो इसका मतलब ये जो 5t हमारा फोर्स है वो दो चीज़ों में जा रहा है. पहले तो वो लोड को बैलेंस कर रहा है, देन प्लस फ्रिक्शन फोर्स. नाउ moving ahead, we have used the same formula which I have told you, that L plus R is equals to 5E. So L, since load is 5 Newton and 5 effort is as already calculated 1.25, so we will get R is equals to 6.25 minus 5 is equals to 1.25. एक क्वेश्चन आप लोग के दिमाग में और आ रहा होगा कि सर ने बताया था L प्लस E इज इक्वल्स टू 5t और वहाँ पे फॉर्मूले में लिखा है 5E. सो बेसिकली आप देख सकते हैं कि L इज ऑलवेज इक्वल टू T इज ऑलवेज इक्वल टू E. So in here this T is replaced by E, so I have written the equation as L plus R is equals to 5E. Now I hope this point will be clear to you. Now this question is about gears. So before getting into the numerical, you should look at the formula for the gear system given in your book. I have also given a video about this gear system, so you can understand the formula from there also. So speed for first gear is given as 180 rounds per minute. RPM stands for rounds per minute. Speed for gear B is 60 RPM, that's round per minute. Radius for the gear B is also given. First we have to calculate the gear ratio. So gear ratio is equal to NA upon NB. Now from the formula, NA upon NB can written as NB upon NA. So I have written NB upon NA, and NB is equal to 60 and NA is equals to 180. So on solving we get 1 upon 3. So 1 upon 3 is your gear ratio. Now in the second part you have to calculate radius for the gear 2, that is radius for the gear 1, that is gear A. So we know that RB upon RA is equals to NA upon NB. Now we have to determine RA, so taking RA to the opposite side and cross multiplying we get RB into NB upon NA. Putting the values and solving we get RA is equals to 5 centimeter. Now heading towards question number 24. In this question you have been given gear ratio, radius of the first gear, teeths in the first gear, and speed of the first gear in rounds per minute is given. Again, first you have to calculate teeths in the gear B. So gear ratio is equals to NA upon NB. Gear ratio is given as 4 and teeths in the first gear are 20. So just cross multiplying and solving we get NB is equals to 5. Now, so this is your part B. Now in the part A we have to calculate the radius of the gear B. So you can easily make out that NB upon NA is equals to RB upon RA, and solving this particular equation for RB we will get RB is equals to 4.5 mm. Now again, using the same formula, NA upon NB is equals to RB upon RA, NB can be calculated. So your NB will be equal to, on solving, 240 RPM. I think in this numerical there are basic calculations are there, so I think you will find it easy to understand. Now move to the question number 25. This question basically belongs to inclined plane. So the angle of inclination is given as 30. Now we know that velocity ratio is equals to S upon H. Now this slant height is represented by S and this straight height is represented by H. Now since S upon H can also be written as 1 upon sine theta, and theta is given as 30, so 1 upon sine 30, and putting the value of sine 30 is equals to 1 upon 2 will get reversed, so velocity ratio is equal to 2. Similarly MA, since MA is also equal to 1 upon sine theta, you can refer to the formulas which has been explained. So you can easily calculate MA is equals to 2. Now next question is क्वेश्चन बेसिकली आपको ये कह रहा है कि एक कोई आदमी है, वो इंक्लाइंड सरफेस पे 2 मीटर जाता है, तो आपको बताना है वो कितना हाइट चढ़ेगा. सो उस हाइट को बेसिकली मैंने एक्स अज्यूम कर लिया है. ये बेसिकली हाइट हमारा एक्स है. सो नाउ वी हैव sin 30 is equals to, since sine is equals to perpendicular upon hypotenuse, so perpendicular is x and hypotenuse is 2, and sin 30 is also 1 upon 2, so 2 will get cancelled, we get x is equals to 1 meter, which means if a man walks 2 meter on an inclined surface, he will gain a height of 1 meter. Now moving ahead to the last question of this video, which is question number 26. So इस क्वेश्चन में बेसिकली आपको एक ग्राउंड दिया है एंड एक रैंप दिया है जिससे स्टेज पे जाना है. सो एंड द लेंथ ऑफ द रैंप इज़ 1.5 मीटर. सो 1.5 is equal to s as the standard notation tells us, and BC जो है हमारा height है उसको हम लोग हमेशा h से represent करते हैं. Now sin theta is equals to h upon s. अभी now therefore we know that velocity ratio is equals to 1 upon sin theta. So 1 upon sin theta. Now replace sin theta by h upon s. So we'll get, now replacing the value, VR is 1.5 and this s will go here in the numerator. So and the value of s is 1.5. So replacing s by 1.5. Now this 1.5 and 1.5 will get cancelled, so we get h is equals to 1 meter. Now again we have to calculate mechanical advantage. So ma is equals to 1 upon sin theta is equals to s upon h. Again ma, now since h is 1 and s is again 1.5, so the value of ma will be equal to 1.5. Now moving to the next question, we have to determine the maximum effort required to bring this sphere required. So इस स्फीयर को बेसिकली हमें रोल डाउन करते हुए स्टेज तक ले जाना है. सो इसके लिए आपको मिनिमम एफर्ट कितना चाहिए होगा. सो अगर जो इस स्फीयर का मास में m अज्यूम करूँ, सो इट्स वेट विल बी एक्टिंग डाउनवर्ड, एंड इफ दिस एंगल इज थीटा, this angle will also equal to the theta. Now this mg can be broken into two parts, mg cos theta and other one is mg sin theta. Now you can see that this sphere is going downward with the force of mg sin theta. मतलब ये जो sphere है वो नीचे किस force से जाएगा, so force वो equal होगा mg sin theta के. Now अगर जो sphere को आपको ऊपर ले जाना है, then you have to balance this mg sin theta. So which means if I apply an effort of mg sin theta, we can simply at least balance the sphere. So minimum effort is E is equals to mg sin theta. Now m is given to you 150, g is 10 and the value of sin theta is 1 upon 1.5. So if I remove decimal, I can increase 0 in the 150 and solving we get 1000 Newton as the effort. This is the minimum required effort. Now I hope you people will understand this video properly. If you have any problem, you can ask me through WhatsApp. And एक चीज़ और भी है, बहुत सारे background music चल रहे थे. Actually I was recording the video in my garden, therefore there were lots of birds. So I hope you will not be distracted from all these kinds of sounds. So thank you very much.